Once the form sheet is generated, this is what it's going to look like on SLIKWORKS. Um, each component which is in the architecture is going to be shown, and you click on this drawer button and then it shows all the failure modes associated with each of these components. For this example, all these failure modes are predicted based on a database that we've developed. This particular database is again based on the ISO 26262, but there is also some additional information we provide SlickWorks in terms of signal names from components that need to be detected. So, for example, if we talk about accelerator pedal sensing, it has some uh, inbuilt failure modes, and then it also has some communication failure modes, which it gets from the diagram. So, for now, we look at accelerator pedal sensor, and then we can look at one of the failure modes, which is stuck in range. Now, it does a combination of each failure mode with every every effect, and it predicts this. So when we need to do a modification, all we need to do is click on a box and then say we have a sensor which is accelerator pedal sensor one, and it's stuck in range. And if it's stuck in range, it could it lead to unintended vehicle acceleration? Probably can, yes. What's the severity of this event? The severity of this event would be it's a safety hazard, so let's call it, let's say it's 10. This is rationale that it comes up by default. You want the user can modify it. So here we're just going to say unintended acceleration city critical. Now what happens is everywhere where there is unintended acceleration, it's going to get stored as the rationality and the severity is going to get updated. Then we have a cause, in which case we assume one cause over here, which is the mechanical jamming of a sensor. So for whatever reason, Hall effect sensor is jammed, it only reads a certain value. Then we go into occurrence. With occurrence, we can find out, we can say the occurrence is, let's say, very low because it's a proven in use component. And then in terms of safety mechanism, we say we have the accelerator pedal monitor. We can select this. And then we say detectability, stuck sensor faults. You have two sensors. Um, as long as you have two sensors, you should be able to detect stuck sensor faults pretty easily. So I'm going to say this is high detectability, which gives it a very low value. And I'm going to say high diagnostic coverage. And what the tool then does is it's going to automatically store this value. It's going to calculate an RPN and action priority. See, the action priority is medium, and then it sets the progress. And now, if this needs to be sent for review, you can change the, and then recommended action, no recommended action for now. Similarly, we can evaluate the next one, which is the loss of vehicle acceleration. With the loss of vehicle acceleration, can a stuck sensor lead to a loss of vehicle acceleration? Probably, if you want 100% acceleration, but it's stuck at 1%. Is this the severity? Is I think the severity would be 8. This makes sense. Is this a hazard? It could be a hazard when you are in performing an evasive maneuver, but again, the probability of that is very low. In most scenarios, it is loss of a primary function. Again, with occurrence, we're going to say it's proven in use component. With the safety mechanism, again, the safety mechanism, the accelerator pedal monitor should be able to detect it. Detectability is 2, rationality, high, diagnostic coverage. And I'm going to set this to in review, and this is autosave. Now, one of the cool features of SLIKWORKS is the ability to filter and look at information. So, for example, uh, you could use the expand all to just expand all the failure modes. You can just go to collapse all, just collapse all failure modes. But if I want to just look at a few columns, you can just go here and say, I just want to look at everything, only the RPNs. Maybe you're not interested in all of this. So makes filtering very easy. Now you also want to say, okay, so now I want to filter using all where the status is in review. It just shows up immediately. Now, if for some reason we thought that this we wanted to add a safety mechanism, it can be easily added over here. So we go here and we say new safety mechanism description, add measure. Then I can just straight away go into this and say I want to add the new safety mechanism as well. And there you go, it gets added. So if I go back to safety mechanism, it will show the new safety mechanism added over here. Last but not least, we have metrics. These are some of the metrics that it shows. We've rated a few components. It says 5 out of 348 of them are rated. There's still another 343 rows missing. What it means by missing is they're still not, the rating is still not done. 1% is complete, so still 99% left. Now, in addition to action priority, you can also look at the RPN distribution. Here it shows the RPN distribution, and you see there are some line items that are finished rating, and it is rated up to 250, which might be a little high. So something needs to be done about it. Similarly, you can see the RPN rating, not the RPN rating, but the severity versus occurrence rating. And this would be on a scale of 0 to 100. So a high severity, high occurrence also might signify that some steps need to be performed to lower the occurrence. Similarly, severity detectability, a high severity times detectability would also mean we might want to do something to lower the detectability. This is now an example of how an FMEA can be done using SLIKWORKS for an electric powertrain.